Greetings, dear viewers. Today, you and I will dive into the world of modern agricultural technologies and incredible machines that are revolutionizing the sowing of grain crops, their harvesting, land cultivation, as well as the processing of waste from such activities. Let me introduce you to seeding technology, an innovative approach that transforms farming into a highly efficient and stimulating process. One of the key aspects of technology is the use of process machines. These unique devices reproduce the natural processes of plant growth in controlled conditions. They ensure the optimal location of the seed and its sowing depth, which ensures an even distribution of grain crops on the field. We also now have access to advanced navigation and control systems that allow machines to operate with high precision and efficiency. Global positioning systems, GNSS, and sensors reduce time and resource losses, making seeding a more accurate and faster process. The variety of technologies also includes the use of drones to monitor the condition of crops. These unmanned aerial vehicles are equipped with specialized cameras that allow obtaining detailed images of fields with high resolution. This allows farmers to quickly identify problems such as plant diseases or stunted growth and take the necessary steps to address them. Another exciting technology is the use of robotic irrigation and fertilization systems. These automated machines allow you to work continuously, ensuring optimal irrigation and fertilization of the field. They have high accuracy and reliability, which contributes to the effective growth of grain crops. The result of the use of technology in the sowing of grain crops is impressive yields. Modern agricultural technologies help farmers to increase production and obtain better quality products, which is the key to sustainable development of agriculture. And so, crop technology is changing the way we grow food. With the help of telescopic machines, navigation systems, drones, and robotic systems, we create more efficient, precise, and sustainable agriculture. These new technologies help us meet the growing food needs of the population, ensuring the sustainable development of agriculture in the 21st century. Harvesting of grain crops is the most intensive and important technological process of agricultural production in agriculture. The main requirement for harvesting is that it should be carried out in optimal terms and without losses. For this, it is very important to correctly establish the dates of the beginning and duration of harvesting of this or that crop. Methods, separate or direct harvesting, in each farm. Premature mowing in the swaths leads to a lack of harvest due to the receipt of thin and inferior grain. Late harvesting is accompanied by large losses from self-shedding of crops and biological losses due to a decrease in the amount of dry matter accumulated in the grain. Losses of stale bread increase especially sharply when precipitation falls, which contributes to an increase in their lightness. The sample ratio of milky, waxy, and fully ripe grain phases in a sample for different crops before the start of bread cutting should be optimal. Based on specific conditions, condition of bread and weather, the method of harvesting is chosen. Great responsibility for choosing the optimal method of cleaning rests with the agronomic service of the farm. A good result is given by a reasonable combination of them. Farming specialists choose the method of harvesting each plot based on local climatic conditions, the condition of the plants, and the availability of harvesting equipment, taking into account the optimal agro-technical harvesting period. Combined harvesting of grain crops can be 1, 2, and 3-phase. Single-phase harvesting, direct harvesting, is a technological process in which plants are simultaneously mowed and threshed in one pass of the harvester. Single-phase harvesting is used in non-clogging areas where plant seeds have fully matured, for crops that ripen at the same time, as well as for low-stem plants, and for thinned crops with a stem density of less than 300 plants per 1 square meter. With direct harvesting, the highest productivity and the lowest energy consumption, fuel consumption, and the total cost of harvesting are ensured. Two-phase harvesting, also called separate harvesting or separate combining, includes operations of mowing grain crops into swaths with a row harvester or combine, picking swaths and threshing with a combine with a pickup. In a separate way, as a rule, littered winter cereals and varieties that are prone to lodging, which fall off easily, as well as crops that ripen unevenly, are removed. Plots of grain crops for the separate method should have a density of at least 350 plants per 1 square meter, and the height of the loaves should not be lower than 70 centimeters. The three-phase harvesting consists in mowing the plants in swaths, the subsequent selection and delivery of the entire biological harvest to a stationary plant, where the bread mass is threshed. The technological processes of harvesting also include receiving grain and transporting it by current, harvesting from the field and scraping straw and floor, processing grain by current, drying grain. If with direct combining, harvesting begins when the grains are fully ripe, Then with separate harvesting, the sorghum can be started several days, usually 4 to 7, before the grain is fully ripe and finished earlier, which eliminates losses of grain from shedding. When the rolls are threshed, up to 80% of conditioned grain is obtained, which does not require drying and additional cleaning, which reduces time-consuming work on currents and accelerates the rate of grain removal. As experience shows, the most rational is a skillful combination of direct and separate harvesting, when the advantages of both methods are used and there is an opportunity to harvest in the shortest time and with minimal crop losses. Three-phase cleaning involves threshing ears of grain, while the combine is in a stationary position, usually on the side of the field, and the threshing mechanisms are powered by an electric motor. Thanks to this, energy costs are reduced, and the total cost of harvesting is reduced, and most importantly, weed seeds are not scattered over the field. However, due to many technical difficulties, this method has not yet become widespread. In each farm, the harvesting method is chosen for each field, taking into account the following specific conditions: the state of the site and its stemness, degree of clogging and maturity of the massif, species and cultivars, actual availability of harvesting equipment and labor force. In the future, we will talk with you about innovative technologies for harvesting hay, in particular about baling, which has become much simpler and more efficient thanks to new developments. Let me tell you about the exciting opportunities that modern technology offers us in this field. One of the key innovations in hay baling is the use of modern balers. These machines are designed with efficiency and precision in mind, enabling the rapid formation of uniform and stable hay bales. They work automatically, requiring minimal effort from the operator, and providing high productivity. Thanks to the latest technologies, bales have become much more compact and better packed. This ensures high-quality hay storage, reduces losses due to damage or exposure to weather conditions, and allows for efficient use of storage space. In addition, modern hay harvesting technologies include automated bale loading systems. These systems allow convenient and efficient transportation of bales to the storage location. They have high speed and accuracy, which ensures efficient use of working time and reduces the risk of bale damage. Another interesting technology in the field of harvesting hay is the use of humidity and temperature monitoring systems. These innovative devices allow farmers to control hay storage conditions to avoid spoilage or loss of quality. They provide optimal storage conditions and help preserve valuable nutrients. And in this way, thanks to the latest technologies of harvesting hay, we get fresh, juicy, and high-quality hay for our animals. High efficiency of modern balers, compactness of bales, and automated systems help us save time, effort, and provide our animals with quality feed. Therefore, innovative hay baling opens up new horizons for forage storage. Modern technologies allow us to provide optimal storage conditions and preserve the quality of feed to maintain the health of our animals. Continuing the topic of straw, let's touch on the topic of straw processing. Straw, depending on the form in which it is collected, on its moisture content, on its chemical composition, on its type, cereals, rapeseed, and on the growing conditions of plants, can act as an energy raw material in different ways. The main technology for processing straw and stalks into an energy carrier can be biogas, which ensures not only the production of biomethane, but also the return of macro and microelements and lignin to the soil in the form of organomineral fertilizers, which contribute to soil deoxidation and the formation of humus. The technology of processing straw for energy purposes is divided into three main operations: obtaining energy raw materials, preparation for burning, and actual combustion. The processing of straw into biofuel is complicated by the fact that straw contains a large amount of chlorine and nitrogen, that is, elements that, during combustion, cause increased emission of nitrogen oxides, NOx. The silicon and potassium contained in the straw make it difficult to operate the plants. The moisture content of straw intended for energy purposes should be about 10–20%. Its energy value is extremely high. In order to achieve economic returns, increase the calorific value, heat of combustion, of solid biofuel, and ensure ease of transportation to heating plants and ease of control of the combustion process, biofuel is processed into granules, pellets, or briquettes. During this process, raw materials are pressed under high pressure. About 3% of energy is spent for the production of pellets. Solid biomass briquettes and pellets are a real alternative to coal and oil, as they are not inferior to hard coal in terms of their characteristics, not to mention the environmental benefits. Straw and stalks of agricultural crops are a rational energy raw material for the production of biofuel, due to their high caloric content and content of dry organic matter. Plowing is the most important method of basic soil cultivation, which ensures turning over, crumbling and loosening of the soil layer. Thanks to plowing, the volume and porosity of the soil increases, weeds are cut, plant residues and fertilizers are wrapped in the soil. They are plowed in the established agro-technical terms at the physical maturity of the soil, that is, at a relative humidity of 40–70% of the full moisture content. If the soil squeezed in the hand crumbles into small lumps upon falling from a height of 1.5 m, this indicates the physical maturity of the soil. At this time, the least effort is spent, the soil does not stick to the tools, does not spray and crumbles well. When plowing over-moistened or over-dried soil, large blocks are formed. With ideal plowing, the soil layer is turned 180 degrees, crumbles into structural aggregates approximately 13 mm in size. Plant residues and fertilizers fall to the bottom of the furrow. The depth of plowing depends on soil and climatic conditions, biological characteristics of cultivated crops, the degree of weediness of the soil, etc. Plowing to a depth of up to 20 centimeters is called shallow, 20, 22, ordinary, over 22, deep, and over 40 centimeters, plantation. Plowing improves the physical properties of the soil, porosity, water permeability, aeration, etc. Under its influence, moisture is better absorbed. The use of nutrients not only from the soil, but also from fertilizers is improved. The fight against weeds, pests, and pathogens is more effective. There are two main methods of plowing, rowing and reversible, smooth. Squad plowing, plowing the field by separate squads. It is practiced on fields of a rectangular or close shape. For such plowing, the field is divided into straight furrows, the length of which depends on the size of the field, and the width ranges from 40, 100 to 100 to 140 m. First, the odd furrows are plowed in a row, and then the even furrows are plowed in a row. This reduces the number of furrows and ridges by half, and better alignment of the field is achieved. During row plowing, the unit moves from the middle to the edges of the fold, while the furrows remain open at the edges of the fold and the fallow ridge in the middle. Row plowing, during the execution of which the unit moves from the sides to the middle of the row, is called plowing in rush. At the same time, ridges are formed on the edges of the plow, following the plow to the right, on the unplowed area, and an accelerating furrow is formed inside. Smooth plowing, shelf plowing without ridges and accelerating furrows. The absence of furrows and ridges increases the quality of plowing and improves the working conditions of planters and other machines operating at high speeds. Smooth plowing is implemented in mountainous areas, on irrigated lands and on experimental fields, because after it there are no separating furrows, nor fallow ridges are implemented on the field. For this purpose, special balancing plows, with two body sections, right and left. Reversible plows, each plow with right and left bodies, and other plows and tractors with two-way movement are used. I hope you enjoyed watching this video. I appreciate you watching until the end. Don't forget to like and subscribe to the channel so you don't miss new videos. It motivates me immensely. Good day.